Here. Okay, let's go. Here's what we're doing, okay? We just finished doing expansion from here to here, and then we wrote something into, okay? This was expansion, which I told you 90% of the time we're not going to do. What we are about to do is this fancy process called completing the square. It is the process to take us from here back to here. Okay? And I want you to keep in the back of your head the fact that what we just finished doing all morning, finding the vertex. Okay? That's what's important with vertex form, is we're able to read the vertex. So this is called completing the square. I'm just drawing two arrows from your nicely drawn quadratic flowchart, which some of you have just mysteriously lost. Despite my best efforts in saying this is the most important piece of paper you'll ever own. Vanished. Somebody stole it, they said. It's so valuable. Okay? You can choose to write that or not. It's already on your flow chart. This is what we're doing. We're highlighting this specific portion of the flow chart. Okay? So, to convert from standard form to vertex form, we're going to complete the square. We are using words that you have seen before. And I'm not referring to the word the or words like it. Perfect square. We've seen the word perfect square before. Right? When we did Coco.
So when we were like refactoring about the perfect square thing, I always thought it was only like when it was two. Like
That was difference of squares.
that's the, oh.
Difference of squares was a special version of kind of a perfect square trinomial. Kind of, not really, but it kind of is, but not really. It has one sign's positive and one's negative.
It's not perfect square.
No. But the idea looks similar, is I think what Coco's getting to.
Like the ugly duckling.
Perfect square were the unique ones that like you had two of the same piece. X plus 3 squared, for instance, right? You got two of the same piece, you got one x answer. X equals this. That might be on tomorrow's test. Well, it will be on tomorrow's test, right? If you square root 0, what does that mean in the discriminant? One answer. Okay? So, when we expand, we get x plus h times x plus h, right? I'm just expanding this thing down here, generally. So I get x squared plus xh plus xh plus h squared, which turns into x squared plus 2xh plus h squared. Okay? H is just a number. Could be anything. Okay? So, here comes the fun stuff. Step 1. Let's write the steps. Ensure x squared is all alone. Okay? Which means nothing in front or no a value. Okay. I'm gonna make, yes, Ibrahim?
Let's say there is an a value in the next.
That's tomorrow's issue. I make it one step harder. Then you need to bring your 5-point harness to school tomorrow, because we're gonna go real fast.
There is a question on the back that has the number.
It should. Oh, don't worry. Don't stress. Nobody look at the back yet. Okay. Just keep your eyes on the road, please. I will drive. Okay. Don't you stress about that yet. You haven't done one question yet. You're all looking at the back like. Just relax. Okay. I'm gonna make up this special little thing. This is like a little value that's near and dear to my heart. Okay. You could call it anything you want. You can make it your own. I call it a Z value. You can call it whatever you want. Z is my thing. I like Z. Because they don't use it very often. Okay? Z is equal to B divided by 2 squared. You're just writing things, okay? You're just along for the ride here. Just write things down. Okay? Kind of a subset here is find Z. You need to find this every single time.
Well, where'd you get the Z?
It doesn't matter. I just made it up. You want a smiley face?
Yeah, so how can you just do that?
What do you mean? I'm just making it up. It's a part of the process. I didn't make it up. I'm just making up the variable. The right side is the piece that's not made up. The left side is I can make it whatever I want.
Then you make it a Z.
Yeah, I'll make it back to a Z for everybody.
You should make it into a bad one.
It'd take too long. It is called. Never mind. There's a B value in it. It's just getting too confusing. Okay, it's Z. I've decided. Okay. You're always going to find Z. Why don't we just do this in order then? So the first two things I've written here, is there anything in front of x squared right now? No, there's a 1. That's it, which is nice. That's what you're looking for, a 1. Okay. Second step, let's find Z. Okay. Okay. I don't think I've, maybe not. I don't know if I've left you enough room. Okay. That's your rule. Z is just find Z all the time. Okay, step 2. So let's find Z. Z we said was equal to B. Where's B? What is B? Did I just make B up?
6.
It's 6. It's the B value from the equation, 6. So we're going to divide 6 by 2, and then I'm going to square it. Is it 36 divided by 4? Actually, yes, it is. Yeah. Is it 36 divided by 2 is my question. No, it's not. I would do the inside of the bracket. It's just what? It's 3 squared. Okay? You do the brackets inside the brackets first. Unless you know how to do exponents properly. But don't make a mistake, because I'm looking for mistakes. So what do I get? 9. Z is 9. Okay, that's good. Fine and dandy. No issues. We haven't done anything too crazy yet. Okay, this just is what it is always. If you see complete the square or convert from standard to vertex, you're finding Z. Is anybody like lost right now? Haven't done anything too crazy yet. No, no. The light has not gone off. We're driving an airplane now. I don't know. I was just saying. You know how the airplanes, they have the seatbelt light? That was my joke. The light hasn't gone off yet. We're flying an airplane now. Okay. Step 2. Here's what we have to do. I'm going to write this in a different color so you guys can see the segregation. Add Z and subtract it. Here's the part that everybody doesn't like. Just everybody relax. Just relax. We're going to add it and subtract it at the same time. And something magical is going to happen. Okay. Here we go. Here's the other little tidbit. You're going to leave this number on the end alone. Just throw it away for a minute till the very, very end. Okay, just throw it away. So I'm only interested in these first two pieces here. Two terms, first two terms, okay? So here's what's going to happen. We're going to open some brackets. Is everyone following I don't know. This is just my way that I figured this out. Everybody just like go with the program and it should be fine. Okay? I figured this out after a lot of time. The best way to do it, I think, anyway. Okay? So, y equals. I'm going to open a bracket. I'm going to write x squared plus 6x. Nothing's changed yet. Step 2 here says add z and subtract z. What's z equal to? 9. Plus 9, minus 9. Close the bracket, minus 1. Have I changed the equation is the point. That's why we've added and subtracted. I know people are going to be really angry with the add and subtract piece. Okay? I know they're going to be like, this is stupid. Why are we adding and then taking the same thing away? You'll see in 1 second. Something magical happens. Just got to keep going. Okay? Just do this process. Okay? Throw the number on the end away till the end. We'll deal with that later. Open the brackets, and then I'm about to show you the magic piece. Do these look nice to anybody? No, okay. Maybe, maybe not. They look very nice to somebody who has an eye for nice looking math. You guys know this, right? What I'm going to say here is factor it. Hold on, I just want everybody just to kind of get in the right mindset here. Factoring is a very troublesome word for some. You can factor that. What kind of factor are we going to use? It's a simple trinomial, sure. But it's a special kind of simple trinomial.
Well, what about the -9?
Don't worry about that yet.
Okay,
Just relax. It's a perfect square. What can we do?
square root first.
Square root the first. Here, I'm going to change the color so you can see. Square root the first. Square root the last. Take the sign from B. X plus 3 squared minus 9 minus 1.
Wait, I have a question. So, you said take the square root from the first and the last, but isn't the -9 last?
No, just from the 3 terms. So I've added 9 and I've subtracted 9 very strategically. I always, listen, I always do it in this order. I add 9 and I subtract 9.
Where did the 6x go?
What happens if I expand this?
Oh, okay.
What comes back if I expand that? X squared plus 6x plus 9. I don't care if you know how to factor perfect square trinomials. You're going to learn to just recognize square root first, square root last, and that is factoring perfect square trinomials. Yes, Rad.
The other way I've seen it, does it really matter if you put the -9 outside or inside the bracket to start?
It does.
It does?
I'm doing this on purpose because of tomorrow's lesson.
So it does matter.
It does matter for tomorrow.
I've seen it both ways.
It matters for tomorrow. But same thing with, yeah. I'm setting you guys up to be the most successful. Just I'm gonna give you one way to do this always, and with a few extra little trickles tomorrow. Okay? What's the vertex? I knew this is gonna blow everybody's mind. It's just, but trust me, if we just do this, I don't know how to write this into. Let's say the next step is factor the perfect square. I ran out of room. You're going to factor the perfect square trinomial that appears. And then you're going to collect the remaining like terms. This is now in vertex form. I would say the last step, state vertex. I would just make it a habit of just stating the vertex. So what's the vertex here? -3, -10. Okay. This is probably one of the most wild things you're probably gonna do in this course, that are a little bit like out there in terms of why am I doing this? Okay. You just do it, and things happen. Because we have one goal in mind, is to state the vertex, basically, right? So in order to do that, I gotta switch it to look like vertex form. That's what this is doing. Okay? Let's do more. Okay, how many questions do we have? I'm gonna do as many as I can, and then you guys are gonna have E to do. So I'm gonna do like 4 questions here.
So that was it, right?
That's it for A. You just follow the steps. There's a little bit of in between the lines, like reading between the lines, but are you asking from a perspective you don't understand what's going on?
No, just
Or
do it. That's it.
it's not bad. It's not bad if you can read in between the lines and what's gone on. The in between the lines is all this box here, basically. But all of that thought goes into like 3 lines.
Can you do the one with the numbers?
Yes, we will do that, but next. Let's do another one. Okay. Huh? The one with the number up front. Trust me, you want to do it like this. You do. Because when I show you tomorrow, you're going to really be scared.
Oh, I see why you have a number inside.
Yes. Okay, let's do the next one. We'll just keep practicing. It's fine. I've got 6 of them here for you. This is what you're going to do with Mr. Lin this afternoon. Okay? All of period 3, you're just going to complete the square. And I will, you know what? Here's the nice thing about this. You can complete the square on anything. I could write any jumbled trinomial on the board. You can complete the square and write it in vertex form. It's kind of magical.
But why though?
So you can state the vertex.
What if you don't need it?
I'm going to make sure that you need it with the question that I ask.
Just like cross it.
No. Okay, let's do the next one. What's the first step? This is good practice. What's the first step? Is it Z? No, it's making sure that the number out front is 1. Is it 1? Yes, okay, so let's find Z now. What's Z? Z is equal to B divided by 2 squared. B is 12 divided by 2 squared is 6 squared, not cubed. It's 36. What's the next step? Add Z and subtract it inside of some brackets. Okay, you're going to throw the number away to the end. Y equals, I'm going to move this up a little bit, save some space in case I need it. Y equals x squared plus 12x plus 36 minus 36. Put that in brackets. Then, actually, you know what? It doesn't go after the last term. It goes after the third.
But that's what I asked him.
Sorry, yeah. Sorry.
Are you sure?
I'm pretty sure.
No, because
Tomorrow's we do another set of brackets. Just trust me. It's okay. It's okay. Just do what I do. Just come along for the ride. I'll put you in first class if that's what you need. Just come along. You can have all the popcorn and peanuts you want up in first class. Just come along for the ride, please. Okay? Okay, and then don't forget the plus 22 at the end. Tomorrow, Retta, it will matter. And I will show you tomorrow it will matter. Okay? Yes, Justice?
Why didn't you put the bracket in that spot at the first one?
That's my bad. I got too excited. I was having too much fun explaining this to you guys.
Tomorrow, are we gonna be putting it inside the bracket or outside?
There will be 2 sets of brackets tomorrow. You'll see. Okay? So, the reason why I put the bracket where I did now is because this actually highlights the fact that it's a perfect square trinomial. Right? You can factor that as a perfect square trinomial and the factors don't move. The brackets, sorry. So, I need 2 numbers that multiply to 36. You know what? You can do this one of 2 ways. You could find 2 numbers that multiply to 36 and add to 12. What are those 2 numbers?
Probably 6 times 6.
Probably is the right answer. Is it positive 6 and positive 6? What's negative 36 plus 22?
-14.
You know what? I don't care how you guys factor it. I don't care if you recognize it as a perfect square trinomial and square root first, square root last. I don't care if you do it that way. I don't care if you do it like this. The important part is you come up with the same 2 numbers, 6 and 6. And they're both positive. That's what matters. Hey?
When you complete the square, isn't it always gonna be a perfect square then?
Yeah. See, by the time you do 6 of these things, it like the factoring part does not actually matter. You recognize it is factoring, but you're not showing me the steps anymore. You're free to write it from here to here. You know what I mean? What's a vertex? Okay. Now, is everybody who does this just hates this because they have to factor? Okay, you're probably not alone. Here's what's magical about the Z value. I love the Z value. Can anybody find a relationship on the page without yelling it out with that number and somewhere else on the page? This is like finding Waldo. Where's Waldo? I want them to stare at the page for a minute.
I mean, you ask someone, I'm someone.
Okay, but yes, you are someone. But you're the guy who wrote the Where's Waldo book. You know where Waldo is. This is not fun for anybody else. You're ruining the fun. Can somebody else find a relation? Just stare at the page for a second. I want you to find that number 6 somewhere else on the page. Where at the top?
It's 4.6.
What?
It's less than
Oh, I thought you got me excited. I thought you actually found it. Okay, I'm gonna let the author speak now.
I might be wrong, but that's the thing. It doesn't matter. I might have
You wrote.
I have dementia.
Okay. Okay. Where is it?
What did you say?
Tell me where the 6 is. The positive 6. Where is it? Else on the page.
I
Coco.
think I see it. So with the Z in the equation,
Coco wins.
What if you alter?
Look, I want everybody to see this right off the bat.
Say, how does that relate?
Listen, okay, this minimizes all the thinking that you have to do, always, with this process. There's no factoring going on. As soon as you find the Z value, as soon as you divide it by 2, before you square it, that's the number that goes in here. Surprise. It's magic.
Yeah, that's actually not what I was gonna say, so Coco's the author, not me.
What were you gonna say?
I was just gonna say that, you already been eating up. I was just gonna say that you can find the numbers by having 12 and square root 36. It's the same thing.
Yes.
That's what I
But yeah, it comes from right there.
But that's faster.
It's faster. You've already done it.
Does that work every time as well?
Yes, it's staring you right in the face every single time. That's why writing Z is important.
But when you ask the question, do you want it to show all these steps, or can we just do what you said? It was fine well though.
No, you can just do this. We'll do the next question like that. Okay? Here we go. Turn the page over. Now, before we even took off on the airplane, Retta stood up and yelled fire. So that was good. Because then you all turned the page over and were like, there's a number up front. And everybody started freaking out. Yeah, you don't yell fire on a plane.
Wait, you're throwing me on. I hate, is this what you're doing?
What? Did you turn the page over?
Okay, no, I'm good now.
We'll talk about that. Okay? That's essentially what you've done. But it goes back to the fundamentals of factoring. Step 1 is what? Make sure x squared is alone.
Someone's angry.
I'm just emphasizing. Is it alone right now?
No.
What can we do?
Punch 2 in the face.
Punch it. Okay. And then it turns into what? 2's out front. And what's left? X squared minus 8x plus 6. Now this is the question from the other side. Ibrahim.
Is this thing recorded?
Yes. You can go back for all the comedy. It's be like a comedy, stand-up comedy. I'm turning into a comedian.
The video's gonna blow up.
You think so? You guys gotta make it blow up. I can't make it blow up. But you can share it.
I'll share it to my friends.
I don't care. Whatever. I haven't said anything too bad. Okay. Now what? What do we gotta find? We gotta find Z, right? Step 2 is always find Z. Make sure step 1 is always make sure x squared by itself. Step 2 is find Z. So let's find Z. B divided by 2 squared. Okay. So it's be careful with this now. Is it 8? What is it? It's negative 8.
Oh, sorry, I thought you meant 8 or 16.
Sorry.
I was like,
It's negative 8 squared. So we get negative 4 squared. I'm gonna highlight this till after, which is equal to 16. Now what's the next step? Gotta add 16 and subtract 16. Right? To so this might be an instance of we have I did something wrong. Everybody take a little step back here. I'm kind of breaking the rules of factoring here for a second. Again, you're just coming along for the ride. This is a very specific process. What did I say on the other side? Throw the 12 away till the end. Okay? When I did this, here's my problem. Every time I do one of these questions, I do this, and it's because I learned it this way. It turns out, for your interest, it's probably best not to touch that number on the end. You just always just leave it alone. I never got shown that, and it's so ingrained in me that every time I do one of these questions, I inherently factor it out of the last term. Every time. Doesn't matter. So you're allowed to just throw the plus 12 away until the end. You don't have to factor it. I guess it's kind of like factoring like grouping or something, right? I don't know.
Like doing 2 times 6, you just leave it as 12.
You just leave it as 12. Okay? It's just one less step for you at the end, one less thing to worry about.
So you just add it on the outside?
Just add it on the outside, just leave it alone. So you only really, this whole process is really just concentrating on those first two terms. Right? Now, I can go y equals 2, x squared minus 8x, plus 16 minus 16. This, Retta, is where the brackets start to matter. Okay? What I'm going to do here is introduce a square bracket. Okay? This is, I know, new for a lot of you too, okay? This is going to be a lot.
See, but then in practice, it really matter.
It does.
Keep the 6 inside. It's either way.
What's 6? What's I don't see
Instead
6.
of having 12 outside, why don't you just keep the
Again, it'll be beneficial for you tomorrow. It is the same thing, but I'm eliminating an issue that will arise more so tomorrow.
Like if you have like a fraction or decimal and you do that.
Yeah, it's just good to have one process that everybody follows, all the same steps, same sequence, just do the same thing all the time.
Why are the 16 and 12 together?
They aren't.
No, I mean, regular why aren't they?
You'll see in a sec. I promise you'll see in a sec, okay?
Well, what makes you do that? Like, why?
Because I know the process. I'm teaching it to you. You just have to come along. Trust me. It's just come along for the ride. Okay? Where's the magic number? I highlighted in red. You're able to factor the round brackets to take on what? X minus 4 squared minus 16, close the square brackets, plus 12. Last step. Get rid of the square brackets. I see 2 pieces in there. Does anybody have any screaming objections? Does everybody see why the square brackets are there? You have to multiply the negative 16 by 2 to get 32. That's why I put the red square brackets in there. That's why, Coco, the 16 is separate from the 12. You could, yeah, that's why the 16 is separate from the 12. In my experience, I found just leaving the 12 alone it's just one less thing to worry about. You just leave it alone. This is a lot to already process. Like, I'm not saying, like, you don't want to have to worry about 4 or 5 extra things, right? You just leave it alone. You don't have to factor it from the beginning. You don't have to multiply it at the end. Just leave it alone. Okay? Last step is what? Collect the 2 on the end. And you're done. Aside from stating the vertex. X minus 4 squared. What's negative 32 plus 12? Negative 20. So the vertex is what? 4 and negative 20. Okay. I will leave a sheet with Mr. Lin. You guys have all of period 3 to master this process. You can watch the video at the bottom and do the last one as well, okay?